Welcome to Part 1 of Section 5.2, Polynomials, Linear Factors, and Zeros. So we're going to start the notes off today with a review problem. We want to factor x cubed minus x squared minus 12x. My question to you is, what is the first rule of factoring that you do? If you're thinking, look for greatest common factor, you would be correct. So that's what we're going to do here. We have three terms. Is there anything all three terms have in common? If you said an x, you would be correct. So I can pull out one x from each of these. The first term then would be left with x squared, so we have two x's left. Second term is just an x. And the third term, I'm left with just a 12. Now you have to check, are we done factoring? Well, if I have a quadratic trinomial, chances are if it factors, it could be into two parentheses, or into two binomials. Now the x that I first factored out is just going to stay with us. It carries down. So we're going to see, okay, what times itself would give me x squared? Alright, so you got to be thinking, x times x is x squared. Now look at the 12. What are the factors of 12? Well, this could be 1 and 12, 2 and 6, or 3 and 4. And since I want my middle term to be negative 1x, I'm going to go with x minus 4, x plus 3. Now we can always check our work. And to do that, we take the inner product, so negative 4 times x, and add that to the outer product, which is going to be a 3x. And we get a negative 1x. So we know that we have factored it. The next review problem. We want to solve the polynomial x plus 3 times the quantity x minus 2 times the quantity x minus 4. So you might be thinking, okay, what was this original polynomial? Well, we have three factors, so it's probably going to be a degree 3. Alright, now to solve this, it goes back to the zero product property. And when we first talked about this property, we applied it to two binomials. We said if you have two things that are being multiplied together and the product is 0, then either the first factor equals 0 or the second factor equals 0, or maybe they both equal 0. But we know that at least one of the factors has to be equal to 0. So that's what we're going to do over here for our example problem. We have three factors. We're going to set them all equal to 0. So we have x plus 3 equals 0, x minus 2 equals 0, and x minus 4 equals 0. And you simply solve for x. Well, these are nice linear factors, so we get x equals negative 3, 2, and positive 4. Now let's take a factor and let's check. So for instance, I'm going to check 2. I'm going to plug it in to my original polynomial. So I have 2 plus 3. Well, that's 5. 2 minus 2 is 0. 2 minus 4 is negative 2. It doesn't matter what we get when we plug in 2 to all three factors. As long as one of the factors equals 0, our product will always be 0. So we know we've done this correctly. That's going to work the same way no matter which 0 we tried. Now let's move on to some new stuff. We're going to recall that a 0, or maybe we call it a root, of a function is the value where the function crosses the, hopefully you're all thinking the x-axis. And at these points, at any of the zeros or any of these roots, these points, the y-coordinate is always 0, because these are x-intercepts. The relationship between the factors of a function and the zeros is going to be described by the factor theorem. So let's talk about what that factor theorem is. The factor theorem states that if I have a factor, x minus a, then a is a 0 of that function. Or I can think of it as a converse. If a is a 0, then I can write it as x minus a as a factor. Go back to the second review example we did, where we had x plus 3 times the quantity x minus 2 times the quantity x minus 4 equals 0. And we got x to equal negative 3, positive 2, and positive 4. Let's take negative 3. Negative 3 is a 0. I can rewrite that 0 as x plus 3 and put it in factor form. Or if I know that x plus 3 is a factor, you solve that for x and you get x equals negative 3 as a 0. So both the conditional statement and the converse are true. Now let's go ahead and try this one. So example 1 says find the zeros and we're going to graph it. We're going to start with a function y equals x times the quantity x minus 3 times the quantity x plus 5. Well, if I'm going to find the zeros, I better set it equal to 0. Okay, and now we set each factor, since it's already factored for us, we're going to set each one of these equal to 0 and then we're going to solve. So the first one's pretty easy. I just take x and I set it equal to 0. Didn't have to do any work there. Next I'm going to take x minus 3 equals 0. And we solve, we get x equals positive 3. And the next one, x plus 5. So if I know that x plus 5 is a factor, then x must equal negative 5. And there's my third 0. So now I'm going to go ahead and graph this. These do not look like they came out very well. We have an x-intercept at 0, one at positive 3, one at negative 5. So we had 3 factors. We probably have a cubic degree, which means, is it going to go down up for the end behavior or up down? Well, take a look at our factors. We had a positive x here, a positive x from the second factor, and a positive x from the third factor. There's no way we could have had a negative leading coefficient if we were to put this polynomial in standard form. So that means that we have the end behavior of down up. And we're just kind of estimating where our graph is changing at. But the only thing we know for sure is the end behavior and our zeros. Example 2 says write a function in standard form if I know that the zeros are 3 and negative 3. So think about that for a minute. That must mean that x equals positive 3 and x equals negative 3. How can I take those zeros and write them as factors? So I want to take this, and instead of setting this equation equal to 3, I want to set it equal to 0. How about we move that 3 from the right-hand side to the left-hand side? So now I have x minus 3. That equals 0. Or if I do the same thing over here, I'll get x plus 3. That equals 0. These are my factors. X minus 3 times the quantity x plus 3. And I'm going to call this f of x as my function name. I'm not done yet. It does not want it in factor form, but it wants it in standard form. So we're going to multiply these two binomials together. We get x squared plus 3x minus 3x minus 9. Now you may notice that the two binomials are actually conjugates of each other. And when you have conjugates, the inner and outer terms always add up to 0. So my original function is going to be f of x equals x squared minus 9. Example 3. We want to write a polynomial function in standard form now when we have 3 zeros. So we're going to start with x equals 3, x equals positive 2, and x equals negative 1. Well, how can I take a 0 and write it as a factor? You're thinking x minus 3, x minus 2. Remember, we're going to bring over these zeros to the other side. And x plus 1. Let's call this one g of x, just for fun. So now I have 3 factors. But when you go to multiply these, because you need to put it in standard form, you can only multiply 2 factors together at a time. And it doesn't matter which 2 you pick. I'm just going to go ahead and pick those 2, the last 2 first. So I'm just going to rewrite x minus 3. We're going to leave that alone for right now. And now let's multiply, and we get x times x, and then we have x plus 1, or x times 1. Then we're going to multiply both of those by negative 2. And you're going to get really good with combining like terms in your head. So this becomes x squared minus x minus 2. And we have another factor that we need to multiply that with, x minus 3 yet. So let's go ahead and distribute that. So we're going to take these 3 terms and multiply them each by x and then each by negative 3. So when I multiply those 3 terms by x, my degrees basically increase. I get x cubed minus x squared minus 2x. And now I'm going to multiply each of these 3 by negative 3. So I get negative 3x squared. Positive 3x. Be very careful with your signs. And a negative 3 times a negative 2 is a positive 6. So let's go ahead and combine any like terms that we have. We only have 1x cubed. Now x squared, we have negative x squared minus 3x squared. That's going to be negative 4x squared. For linear terms, we have negative 2x plus 3x. That gives us a positive x, and then we just have our 6 left. So there is g of x. To wrap things up, we're going to try another example. Number 4 says write a polynomial function in standard form with the given zeros. X equals 4 with a multiplicity of 2. A multiplicity tells you the number of times that this is a 0. In this case, it's going to occur 2 times. So we write it as x equals 4 2 times. Now you're going to take the 0 and you're going to rewrite it as a factor. So be thinking about the factor theorem. If 4 is a 0, then x minus 4 is a factor. And it's again going to occur 2 times. Now, if you would like to rewrite this as x minus 4 squared, that's perfectly fine. Just make sure that your answer is not going to be x squared plus 16. This is wrong. And to show you, I'm going to go ahead and multiply these together. But first I'm going to give a name to my function. Alright, I'm going to multiply these. X times x is x squared minus 4x minus 4x again plus 16. So I have x squared minus 8x plus 16, not x squared plus 16. There we go.